secret, especially if you're a longtime fan of my channel and projects, that you know that I love adding LED pixels to many of my 3D printed projects. I would say in the 5 years I've been doing YouTube content and 3D printed projects, I would say about 80% of them have an LED strip or a pixel in some form or capacity. What started as a challenge 5+ years ago to recreate a store-bought electronic decor piece using much cheaper LEDs and 3D printing to recreate a similar product you can buy off the shelf, that sparked something in me, I guess, that in the last 5 years has become part of me in this community. It's become a little bit of a niche of mine with 3D printing, and some people even refer to me as the LED person, which I don't know if I'd do that, but cool if you do call me that. That's awesome. Thank you. So today I figured it would be a great day to make this video to tell all of you that you can also add some really cool LED pixels to your next 3D printed project, and it's not as intimidating as you might think. I'm going to tell you guys everything I know from my last couple years of working with LEDs in my 3D printed projects, from LED strip recommendations to what controllers and power supplies you need, and I'll also give you some recommendations with your 3D printers and your filament that you use so that you can take your projects from good to great. So without further ado, let's get into today's video. Hey everybody, Big Jano here. Welcome back to the channel. For those that don't know, I'm an engineer by day, but by night I like to 3D print and create awesome projects over here on YouTube, and I love to share these projects with you live while I'm working on them over on my Twitch channel a few nights a week. There will be links in the description if you guys want to check me out over there. I've also occasionally made 3D printing tutorial videos in the past. We did a lot of tutorial videos early on with my first ever 3D printer back there, and I kind of want to do another one of those today, but this time I wanted to incorporate how to use LEDs in your 3D prints like I do, so you can take your projects to be even better than before. This is not meant to be a huge deep dive video on LEDs themselves or all the applications that LEDs can provide, rather more a video of the things that I've learned in the last 5 years using these LEDs in my projects and the things I've learned along the way, things that I didn't know when I first started using these in my projects, but I want to share with you so that you can take your projects to the next level and make some really cool stuff with it. I'll try to cover everything as quickly as I can and not ramble on about any specific topic, so this video is not 45 minutes long. Hopefully it's not 45 minutes long by the end of the video, but we'll see where we are when we're at the end. That's the goal of today's video, is to inspire you to be able to make stuff like that behind me in your own shape or capacity and see what you come up with. Really quickly, before we start today's video, I do want to throw out one big disclaimer and remind everybody that I am not an electrical engineer. I'm also not an electrician. So please, please, please use caution and safety in mind when trying to utilize LED strips and any supplemental wiring and electronics that you need to get these up and running safely. Do not ever work on electronics while they are plugged in. Do not work on anything while the power supply is on and active, and make sure that everything wired together can be wired together safely so that there are no risks of fire hazard or electrocution. Again, this video is meant just to be a guide on how you can utilize these LED strips in your 3D printed projects, not so much how to physically wire said LED strips. This is not meant to cover that in this video. I actually have covered that in the past in other project videos here on my YouTube channel. I'll put those links in the video description of those videos if you need to understand some more basic electrical engineering knowledge. So if you don't have that, I do not recommend you watching this video. At the end of the day, I am not responsible for you using LEDs or anything electrically unsafe and not as intended. So again, please, please be safe. And if you don't have a basic electrical engineering knowledge already before watching this video, I will recommend some links to channels that will give you a really good grasp on those basics and do much more deep dives on said electrical engineering topics. So I will link those in the description. Go watch their channel and videos first, and then come back to this video once you have an understanding. Hopefully that's the last I have to talk about it. There are going to be options of LED strips that don't require massive amounts of wiring or electrical connections. So there are easier options that I still use on some of my projects that we will talk about. But regardless of whatever LED strip you use, you do need to be safe when using any type of electronics. All right, now that I got the scare tactics out of the way, let's actually get into today's video and let's talk about the basics of what I utilize. And every project utilizes the same few basics. So each of my projects has 3 core ingredients, if you will. The LEDs themselves, a controller of some kind, and a power supply. Each project utilizes all 3 of these for my LED strips to work within my 3D printed projects. However, in some instances, my LED strip and controller can be combined into one entity. Most of the time they are separate, but in certain applications or in certain LED strips that I use, if they have their own special fancy remote that you might get, the controller's already built into the strip or the pixels. So sometimes it's integrated, sometimes it's not. However, a controller is what's operating these LEDs regardless, and the power to let them run. LEDs, or light emitting diodes, are electrical components that give off light when current runs through them. To me, LEDs are kind of like potato chips. Sure, you have your original tried and true LEDs, but there's also so many different varieties and flavors out there depending on what application or what you're in the mood for that day. LEDs are very versatile and also come in many different shapes and sizes. I do not want to make this video a whole boring video on LED knowledge, but I will say that addressable LEDs have fancy integrated chips within each pixel that allows full customization of the red, blue, and green chips within each pixel to get the desired color you're looking for, as well as full customization and control of each pixel in your segment. If you have a non-addressable LED strip, typically you're only able to run one color on that same segment at any given time, and usually at a specific brightness, usually on or off. Addressable LEDs can do a lot more for you and make your projects really great. They do also cost a lot more than your typical LED strip you can find on Amazon that you use to decorate your room. Even if they are fancy LEDs, I do also utilize non-addressable LEDs in my 3D printed projects, depending on the application. If I just need one singular color to show up in my project, then I will absolutely use the non-addressable LED strips, usually one of the cheaper LED strips I can find that maybe has a battery pack or something that just lights up in a certain color to get the job done. If I do need a specific color or I need more control of the lights in my project, then addressable LEDs are what I usually lean towards. The controller is usually integrated within that strip, so you don't have to physically wire any additional hardware. However, if you want to have full customization of your LED pixels, aka using addressable LEDs, then a separate controller is usually wired to the LEDs and to a power supply to operate correctly. Typically with non-addressable LEDs, these are going to be very low powered, usually 5 volts or lower. And with addressable LEDs, this is where your power options come in different variables. You can see 5 volt LEDs, which are actually what I use for most of my addressable LED projects, but you'll also have 12 and 24 volt options depending on the LEDs and what your applications for your project are. So it's very critical that you understand what voltages you need and what your project's going to be. If you're using a large scale of LEDs, then you might want to consider 12 or 24 volt lights in order for your project to run smoothly. In today's video, in my personal opinion, I only use 5 volts for the majority of my projects, as 5 volt LEDs get the job done 99% of the time. I'm not usually using a ton of LEDs at once, so the lower voltage option will work just perfectly fine for me. In the 5+ years I've been doing these 3D printed projects, I have used both addressable and non-addressable LEDs, and now I want to showcase some of my favorite personal recommendations of both categories of LEDs to showcase what you could potentially use in your next projects, and let you guys know what I use for a lot of my projects as well, so you guys know where to go to find these. Before I shell out any recommendations, I just want to let you all know that I will post links to everything I mentioned in this video today, from LEDs all the way to the other stuff I mentioned later. I'll have links to those in the video description so you guys don't miss out on where you can get these. All right, hopefully you guys can still see me. I'm going to switch screens here for this next part of the video so I can showcase different LEDs to you all. And we're going to start here. This is actually on Amazon. I do find a lot of my LED strips on Amazon. There are some other websites I do find LED pixels and strips and different configurations from, but for the most part, Amazon is my go-to for purchasing different LEDs. They usually get here in a decent amount of time. Shipping's not too terribly priced. You might have to pay a couple extra dollars compared to a website like AliExpress, which we will show some options over there too. But Amazon has a lot of what I've used in the past just because of ease of sourcing. Like I mentioned previously, these addressable LEDs all have different codes, and that's all dependent on the type of chip that's integrated into these LED pixels. For a lot of my projects, my bread and butter LED are these WS2812B LEDs. If you type that into the search bar, you'll get a ton of different options, mostly 5-volt versions of these LEDs. I believe they're only 5-volt LEDs with this code, but WS2812Bs are really easy to use and program once you know how to program them, and they are always really solid for my 3D printed projects. I would say this is my go-to LED strip if I need addressable LED strips in any of my projects. What's great about these strips are that they are cuttable, so you can adjust the length of the project you have, and then at these little copper pads, they're spaced out, every couple millimeters apart. You can then actually cut them if you cut them along the cut line and utilize a certain length. So you don't need to utilize the entire spool of LED strips. You can use a certain amount and then cut away the part you don't need, save it for later, whatever you want to do with it. These particular LED strips are from a brand called BTF Lighting, and they are a brand that I really recommend. I have bought a ton of their LED products over the years, and I've never had any quality issues with them. Everything I've bought from them off of Amazon has been super good quality. So if you guys are searching for LEDs, BTF Lighting is a good brand I do recommend. Not all brands are created equal when it comes to LEDs and electronics, so definitely keep that in mind when you're searching around Amazon and AliExpress and other websites. But BTF Lighting is a really good brand. We'll see some other options of LEDs from that brand here shortly. With these particular LED strips, they do come in a black and a white option, as you guys can see. There's also different LED spacing options depending on if you need a more condensed LED section covering in your project, or if you don't mind if they're spaced out quite a bit, you can do that as well. There's different lengths of the spools you can buy. You can buy 3.2 feet up to 16 feet of LEDs. And obviously, the more you buy, they're going to get a little more pricey. They have gone up in price in the last few years, but they're still relatively inexpensive for most of my projects. So these are a really good go-to. They're very versatile. They do have a 3M backing on the back you can peel off and stick to a surface. These also have options for IP67 rated waterproof rating. So if you need them to be waterproof, they do come with a rubber silicone coating on the front of the IP67 version. If you don't need waterproofing, they do also offer an IP65 dustproof coating, which doesn't come with the silicone coating. It just has the LED strip with a very bare backing. So there are different various options with this LED strip in general, but these are a really good starting point to the addressable side of things if you want to get playing around with these pretty quickly. Another option for addressable LED strips are these ultra narrow strips, also from BTF Lighting, but you can also get these from other brands as well. These are 2.7 millimeters in width. These are very, very tiny LEDs. They're very discreet. They still have the same chips as the other WS2812B strips, so it's the exact same LED in a much smaller package. I've used these on my Gingerbread City holiday displays. I've also used these in other tiny form projects that require a very small window of envelope for the lights to sit in. They're very discreet. You can kind of hide these much easier than the bigger strips. And these also do have a 3M adhesive backing on them, so you can't stick them to surfaces in your projects. You can flex these around as well. They also do have a 3-pin JST connector attached to these already, so you can connect these to a controller or power supply pretty darn easily. These are great for smaller projects, but also have the same type of control you would with a traditional addressable LED strip. These particular strips also have a 12-volt option as well if you're into the 12-volt lights. Now these addressable LEDs don't just come in LED strips and singular strips here. You can actually get these in matrices of different sizes. Now on Amazon, there's going to be a limited selection of these, especially if you want to stick with the BTF lighting brand like I usually do. However, if you go onto AliExpress, you actually can get a lot of different iterations of these matrices. These are also the same LEDs as before, the WS2812Bs, just formatted in a matrix or a grid, if you want to call it that, instead of the singular strip. Truth be told, I haven't used these matrices that often. I have used them a couple times in previous projects. If you all remember my one project from a few years ago, my LED matrix display sign that I had sitting back here in the videos and on my live streams, I actually used a bunch of these daisy chained together. I think I had a couple 8x8 matrices daisy chained together in a row of 1x6 to create like a horizontal LED sign display. I had it up and running for a little while. I actually tore it down not too long ago because one of the matrices got damaged during transport from an event. So I think I'm going to be reworking that design in the near future. But these are pretty cool to work with. They are kind of flexible. They also do have the 3-pin JST wired connectors already pre-soldered onto these in most instances. You gotta double check each listing to make sure they are or not. If not, you just have to solder them on yourself. But they are pretty cool to use, and they are also fully controllable like the LED strips themselves. Here's a picture of the 8x8 matrix for those that want to see it. BTF Lighting also has an 8x32 iteration as well as a 16x16 iteration. So they do have a few different options for you to play around with. These are all 5-volt LEDs and the exact same as the strips. One thing to keep in mind if you go with these LED matrices, and something we'll talk about a little bit more in the power supply section of this video, because there are 256 LEDs in this particular instance, that is going to draw a little bit more power than your strips. So you will have to keep in mind the rating of your power supply you use to safely power these and not underpower and or overkill your power supply. Another thing to keep in mind with these LED matrices is that they aren't waterproof. They don't have that waterproof coating on them like the strips might have. So these are going to be used primarily indoors. So one thing to keep that in mind if you do need that IP67 rating. I will say these are really cool to play with in the few times I have used these matrices, and with the controllers and the integration with that, there are so many different things you can do with these. There's a lot of different functionalities, and they just look really cool too, in my opinion. Okay, so another option outside of the LED strips are these LED rings. Now, I don't have a specific brand for these. I've actually used a couple different brands over the past few years. I believe BTF Lighting does have some of these, but on their AliExpress website, not so much on Amazon. But these are really versatile as well. If you find ones that already have the 3-pin JST wires connected like this one right here, it makes it easier to connect multiple rings together, and it's a little bit less time to wire and or solder wires together. It's making it much more simple. But it's what I actually use for my LED lights back here. These Y lights that have LED rings embedded behind each of the diffusers. So these are very versatile. You can actually get them in different sizes, as you guys can see, depending on what your applications are. These really are easy to work with. You just plug them in and they work pretty well. They're the same as the matrices. You just got to plug in the connectors to the controller and power supply, and you should be good to go. If you dig through Amazon a little bit, you can actually find multiple packs of these. You can get a 4-pack. Others have 2 or 3 packs. So depending on what you need, you can look around and find ones that work for you. These have 24 pixels on each ring. And like I said, there's also bigger ones. There's also smaller ones that you can utilize. But I have used these in the past, and they are also really nice to use. Like I mentioned before, if you don't want to use Amazon, or if your country doesn't have Amazon available to you, you can find all of these LEDs on AliExpress. If you type in WS2812B 5-volt LEDs, you're going to get a list of everything and anything. There's actually much more selection here on AliExpress than there is over on Amazon. It is a little bit harder for me to get these off AliExpress because a lot of these are coming from overseas and take a little bit more time to ship and get here. However, they are usually at a lower cost than Amazon. So if you have some time before your next project, you can get some really good deals over here. Again, keep in mind, not all vendors are created equally here on AliExpress, But BTF Lighting is here on AliExpress. They do have a shop along with some other really good brands as well. And just based off this search, you can see there are some pretty decent selections here of these addressable LED pixels you could find. I've actually found a couple things on AliExpress here in the past, such as these right here, these little LEDs that have a little heatsink attached to them, and they have like a clear coated wire connecting each one. I've actually used those specific ones on some of my holiday light projects. So depending on, just go ahead and search around, see what you can find. You'd be actually surprised how many different types of addressable LEDs you can use for your next project. So now I want to cover some non-addressable LED options. What if you don't necessarily need the full control of each LED pixel like I've shown you in all those other addressable LED options? Well, there are some really good non-addressable LED options you can find also on Amazon. I've actually bought this particular link here that I'm showing you right now. These are from a brand called Henry. Hopefully I'm pronouncing that correctly. But what's great about these are actually battery powered. So all you need is a couple AA batteries. You put the batteries in the little battery pack and you connect the little connector to the battery pack, and you actually control these with a little infrared laser remote to change to some basic colors, you know, your typical rainbow colors. They're very basic controls, nothing super fancy, but if that's all you need for your 3D printed project, these are great. I actually used these particular lights on my Disney Cruise Line LED sign that I made my friends last year. I actually made a YouTube short about that. Definitely check that out if you haven't seen it. But these are great. I was able to wrap these around the outside edge of the sign, the display for their stateroom door. And these also have a 3M adhesive on the back, so you can't stick them to a surface. The adhesive's not super great, so you might need some secondary adhesive. But these are a pretty cheap option. You get 2 spools of these for about 16 bucks, and they're 6.5 feet each. So decent amount of LEDs, some basic controls, and they're battery powered, so you don't need to haul around a power supply and another microcontroller, and there's a lot less wiring that has to go into this. You just put in some batteries and they turn on. These are also waterproof as well, I'm seeing, so that's also a plus if you need outdoor applications. Now, another non-addressable LED option that I really enjoy are these fairy lights. Now, these you've probably seen at fancy displays, maybe at like a wedding or something for some lighting effects. These are really versatile because they don't take up a ton of space and they're really easy to work with. They are usually these little LED pixels that are encapsulated in like a clear plastic of some kind, and they're spaced out sporadically on this really thin metal wire. The wire is able to bend pretty easily, so these are able to be manipulated into whatever shapes you want, and they could be utilized in, quite frankly, any type of project if you really think about it. I have used these in a couple different 3D printing projects in the past, especially for some lithophane light boxes that I did for my sister's wedding a few years ago. I also did a couple other lithophane light boxes with these types of lights. They're really easy to use. I don't have to utilize another microcontroller and power supply. These are also battery powered. They're also USB powered if you want to run these through USB. So it makes it easy to use a little portable power supply that has a USB opening to make it even easier to plug and play. While this may not be the exact brand that I've used in the past, I actually forget what exact brands of the fairy lights that I've used. These are all pretty similar in nature. They usually utilize a battery pack that has a couple different functionalities for the lights you guys can kind of see. They have a couple preset lighting effects, and then they usually give you another little infrared laser remote that has some preset colors. So again, if you need something basic with some basic color changes, and if you want to use something really versatile for some projects, I do recommend these in a lot of different applications. Also, there's a couple of different iterations of these that have copper wire versus a clear coated wire. So the copper wire is a little bit more bendable. The clear wire is a little less flexible, but it's cleaner and it actually prevents water and dust from getting into any of the LED pixels, so that might be a good option. But again, these are also very versatile. I really do like using these. Hopefully I have some B-roll lying around of my one lithophane box I have sitting over there with the fairy lights in it. So I'll take some B-roll of that and show you guys what they look like. And they actually have a really good hue to them. They're pretty bright. They really do get the job done for something really simple. So I will definitely throw these in as a recommendation if you want a really nice LED option for your 3D printed projects. Hopefully I was able to show you a nice selection of LEDs, both the addressable and the non-addressable LEDs. These are the types of LEDs I use for the majority of my projects, especially in the last 5 years I've been doing this with 3D printing. So they might not all have the same applications, and I might use some of these options more than others. I do tend to utilize the more addressable LEDs for the majority of my projects, just because I get more control out of them, especially if I'm making these light projects back here, these LED light panels. But I have used all of those options in some capacity in the last couple of years, and I have had great success with all of these different options with LEDs, and I would 100% recommend any of those to you guys. This is the fun part of the project, honestly, is to get creative with what type of LEDs you want to use for your project, especially if you want to incorporate 3D printed parts into it. So get creative and use your imagination and get inspired. I hope this part of this video inspired you to see what's out there. I think that's what a lot of people don't realize, what's out there in the LED world that you can utilize for your projects. So hopefully you get a little bit of inspiration there, and hopefully this will give you an idea of what to expect. All right, we've talked LEDs. Now let's get into microcontrollers. Just remember, these are going to be for the addressable LED options I showed previously. If you decide to go with the non-addressable LEDs, then chances are the controller is going to be kind of pre-built into the lights themselves, and you're going to get this infrared controller or something similar to this, or you might also have just a switch that turns them on and off, or a plug-and-play solution. So you won't need these microcontrollers unless you are going the addressable LED route. Without this microcontroller, there's no way of those LEDs getting any type of signal to let it know what color to run or at what brightness, so it needs this microcontroller to tell it what to do. I have used so many different microcontrollers, and quite frankly, they all really do the same things at the end of the day. As long as you're using a microcontroller that is compatible with those WS2812B strips or pixels or whatever LED you decide to go with, it has to be compatible with that code so it can run effectively. For each of these microcontrollers, we're going to talk about what is needed to wire up to these microcontrollers in order for these LEDs to work effectively. For the most part, it comes down to having 3 outputs on the controller. You have a voltage output, you have a ground output, and you have a data line that it also runs to the controller. Those 3 things are what are built into each addressable LED strip. So you need to be able to wire at least 3 wires to most of these controllers for them to run effectively, as well as running the controller to a power source for obvious reasons to power it up. Keep in mind, this is just for this example for these WS2812B versions of these pixels. If you have a different version of pixels or strips that you're running, you might have a different output number. You might have 2 pins, you might have 4, but for our sake, for these WS2812Bs, we only have 3 outputs here, so that's what we're going to be focusing on this video. So let's talk about some microcontrollers I'm really fond of. In the 5 years I've been doing these 3D printed projects and incorporating LEDs into my projects, these microcontrollers have been my go-to for the majority of my projects. I do use different controllers for different projects based on the application and how many LEDs I'm using, but all of these controllers I'm about to show you all are ones that I would recommend using in projects, and I'm going to show you guys what's great about each of these as well. Alright, starting off with one of my most tried and true microcontrollers that I use for a lot of my projects are these ESP8266 microcontroller boards. These control boards are really easy to program. They're also really easy to get up and running really quickly. I use these for a lot of quick and dirty LED projects. Also, I use these for when I'm only using a very small handful of addressable LEDs, maybe like 100 to 150 or less, because these are very compact and can fit into a very tight space within my 3D printed project if I'm trying to hide it in maybe like a base of something. They're also really inexpensive. You can get this pack of 3 for $17 US, which if I can do my mental math correctly, that's less than $6 a piece, which is pretty good value. You can actually have gotten them cheaper a couple years ago, but in today's economy, that's still a really good deal. These also can connect to your local Wi-Fi if need be. Typically, you only can run up to 2 amps through these at its very maximum. Having a project with a small amount of addressable LEDs, these are perfect for those types of projects. If you're more advanced than me, then you can also take breakout boards and other electronics to wire up and integrate together with these and create even bigger projects that aren't even 3D printing related, but other cool electronics projects. They're really versatile too. I think that's really cool about these. So it's a great starting point. I used these for quite a bit of time until I started finding other addressable LED light controllers, but this is a solid option. And yes, I've actually used this particular brand before. These are the ones I've personally bought over the years. So I will throw this link in the description along with everything else I'm talking about today. What's great about these as well is that you're really only going to need 3 wires connected to this board to connect to the LED strip that's going to be able to control these the way you want to. And then you're also going to use the micro USB port on the top end to plug it into a power supply, or you can also plug this into your computer if you want to do some testing. Again, I recommend only doing this if you're just testing out maybe a small strip if you're plugging into your computer, because it can only run 2 amps through the board and you don't want to burn it out. So just keep that in mind. Anyway, the only pins you're really going to need on this are the VIN, which is your voltage pin that's in the top right of this picture, the GND, the ground pin, which is right below that on the top right, and then the software I use for controlling these LEDs, you're only going to need the GPIO2 pin, which is the bottom left, 5th pin up, I believe. Makes setup super easy. I actually have made wire harnesses that have like little makeshift wire harnesses with one of these LED strip connectors on one end and a partial DuPont pin out on the other. These have female DuPont ends on them. I probably cut off the other end and then just tape them all together, exposing some copper on each wire, twisting them and taping them up. Again, this is a makeshift solution. This isn't super clean. You could probably solder these wires together to make it a cleaner look, but for prototyping, this gets the job done and it works. I actually shown some other videos that I've done in the past on how to wire these up effectively. I'll put a link to those videos up in the top so you guys can see more of a detailed look on how I wire up one of these ESP8266 boards. I recommend going to watch that video. It has a lot more detail and I don't run out of breath trying to tell you. All right, so this next option is kind of a step up from the ESP8266. This is the Gledopto ESP32. This microcontroller is basically an upgraded version of the 8266 I just showed you. This controller is a little bit more user-friendly. It has a nice little enclosure to it. And instead of having open pins on the board, this has a bunch of clamp down terminals where you can just take open-ended wires and run them through and then clamp them down and they stay secure in place. This controller is pretty unique in the sense that it has actually 2 different outputs for 2 separate individual strands of LED pixels. So if you wanted to have 2 different strands of pixels in your project, you could easily do that through the 6 ports that are on the right hand side. You do have different GPIO pins for each set of 3, your ground, your data, and your voltage. And then there's also capabilities to run connections to your power supply directly on the controller itself as well, with the positive and negative voltage terminals on the left hand side. Now, while you will have to run a couple extra wires compared to the ESP8266 to power up the LED strip, this does make it a lot easier with this quick connect design on this controller. And I think that's one of the things I fell in love with this controller about. I'm actually using that controller back here on the central set of lights right here, and it's been great ever since I connected it. I've never had an issue with it. This is a more expensive option than the ESP8266s. However, I do recommend spending a couple extra dollars if you want to dive into something a little more user-friendly and something that is easier to install with your LEDs. This is also recommended if you're going to use a cage power supply, which we'll talk about in the next section here. Basically one of those bigger power supplies that's going to require a lot more power for your LEDs, as this has easier direct access to that power supply through those inputs there. This next option is another really good ease of use option, but what's great about this particular microcontroller is that it has an opening for a DC barrel-ended power connector. So if you're using a smaller power supply that has a DC barrel end to it, you can plug it directly into this microcontroller, turn on your lights a lot easier compared to the last 2 options. Again, great for smaller projects or ones that don't require a ton of LEDs because you are going to be using a smaller power supply in theory. This microcontroller is also a very tiny package system. It's also another ESP32 based microcontroller. It does have a nice little plastic enclosure as well. You do have 4 wire terminals on the end. Those are where you're going to screw in your wires from your LED strip. And then you have the DC barrel connector port on the side, and that's where you're going to plug in your power supply. You can find these on AliExpress for about $20 US each. And I've actually used these multiple times in different projects. I actually have had a handful of these at one point, like 3 or 4 of them. And I'm actually running 2 of them right now with both the light panels back here, and I'm also running one with my LED nozzle back here on the other side of it. So I have 2 of those microcontrollers running those 2 sets of LEDs. They have both been really easy to work with. And they also have WLED compatibility, which we're going to get into here in just a second. One thing to note with these, though, they come with the world's tiniest screwdriver to screw down the screw terminals for your wires. So if you have big hands like me, this little tiny screwdriver that you get is very hard to work with at times. I've had some frustration with that little screwdriver, more than you can think of, but once you get those wires screwed down into the terminals, this controller is super easy to use and you don't have to do anything else with it. The great thing about all of these controllers is that you can actually run the same LED software that I run for almost all of my 3D printed projects, and it's the one I'm going to recommend to you all right here, and that is WLED. WLED is an easy-to-use software. You can download it onto your ESP32 or ESP8266 devices, and it allows you to have complete control over every single LED pixel in your project. The user interface is super clean in my opinion, and there are tons of color and effect presets you can adjust your LEDs to. There are also a ton of other macros and presets you can set up if you really want to get technical and advanced with this, but it is a solid software to use for your LEDs if you want to control them. I use WLED for about 99% of my projects with regards to everything pretty much except for the first one, where I ended up using an Arduino and coding my own code with the NeoPixel library from Arduino. That took a ton of time, and WLED pretty much does all that work for you with a couple clicks. Really quickly, I want to show you guys an example of the interface in WLED. This is the interface for my Y lights, my LED lights that are right behind me. These are like the Y-shaped lights that are kind of interwoven with each other. You set up your controller ahead of time in the system. There's a whole process on doing that. I'm not going to go through all that entire process, but I want to show you guys the interface and some stuff you guys can play around with. It's really cool. I have a running preset right now with these back here with the colors and the effects. They're kind of wavy back and forth. But what if I want to change the colors and the effects? So if I change this to, say, I don't know, let's make a color here, yellow and blue. You guys can see they change colors pretty easily. And say if I want to change the effect as well, let's go with this chase pattern. You can see that this one looks a little better maybe. There's a lot you can play around with here. So there's color waves, there's dissolve. Want to change the color again, maybe like a red. There you go. You can see you can make different segments of LEDs. So say if you want like your first 100 LEDs to have one effect and one color, you can create a segment there. If you want to have another segment with the next 100 LEDs with a different color and effect, you can do that. You can program it in the segment section, and you can then save your presets so you don't lose them after the fact. But everything in this interface is customizable and changeable to mix and match different effects and colors and see what works for your project or application. And if I want to go back to my preset that I had here for my YouTube video, I'll click on this. This is my Stream Palette preset. And we are back to our red, yellow, blue color. Play around with them, see what looks good to you. WLED makes it super easy as well to set up everything ahead of time in the user interface, to set up your Wi-Fi, your LED preferences. This is where you can select what type of LED strip you have. And you can also set up the 2D configuration if you're using a grid or a strip. Interfaces, macros, mod, there's all sorts of fun stuff in here you can play with. I'm not going to get too far into WLED, but for those that want to get into using addressable LEDs in their 3D printing projects, I 100% recommend this software. It is the easiest to use by far, and I have not looked back since discovering it myself. So now I've figured out my LED pixels for my projects, and I've also chosen a microcontroller. Now I need to determine what power supply I'm going to be using and what its rating is. I would say out of everything in this video, the power supply is probably the most important aspect of working with these LEDs, especially the addressable LEDs. And that's just because we need to make sure we have a power supply that can safely run the amount of LEDs we are running and at the correct voltage. When choosing a power supply, I usually stick to 3 simple rules when doing so. Rule number 1 is that make sure you select a power supply with the same voltage as your LED pixels. If you are using 5-volt pixels, you need a 5-volt power supply. If you have 12-volt pixels, 12-volt power supply, and so on. You cannot mix and match LED pixel voltages with power supply voltages. That is a recipe for disaster. Do not do it. In my case, since I mostly use 5-volt LED pixels for all of my projects, I usually select 5-volt power supplies, usually from Amazon or other reputable dealers. Before I show you what power supplies I recommend for my projects, let me get into rule number 2, and that's to measure the voltages required for your power supply based off the number of LEDs you have in your project. Typically, an LED listing is going to tell you what each pixel's power rating is going to be. In my case, for these WS2812 strip pixels, they usually give off 0.3 watts of power per pixel, assuming you're at full brightness. Now, that's assuming full brightness. If you're below full brightness, it's going to be less than that, but the listing should tell you what the exact number is. But what you need to do is figure out how many LEDs you're going to be using in your project. And in my case, since I have 0.3 watts per pixel, say if I'm using 100 LEDs, we're going to multiply that 0.3 by 100, and we're going to get 30 watts. That's going to be the power, the base power we need for our project. Now, rule number 2 and rule number 3 kind of intertwine with each other. And with rule number 3, my rule is always include a factor of safety of an additional 20%. What that means is you're going to take that 30 watts and multiply it by 20% or 0.2, and that's going to add 20% of 30 to that value, which is 6. So that is going to give us 36 watts. So we want to make sure we select a power supply that's going to handle 36 watts or more. And that little bit, those 6 extra watts are just a little bit of cushion for myself, knowing that whatever power supply we select, it's going to be rated to that, and we know it's going to run safely. Again, this was just an example. Please make sure you look at the specifications listed on the LEDs you're using and use those numbers to calculate your own power number to determine what power supply you need and what rating it needs. I actually did a video on this a long time ago when I made my first ever Jano Leaf light panels back there. They were the old triangle ones. I did a video maybe a few years back on that, and I actually showed the math and calculations that I just talked about briefly. So if you want to see that in a little bit more detail and really understand what I'm talking about, definitely go check that video out. I'll also put a link to that up above so you guys can take a look at that in a little bit more detail. I know it kind of brushed through it, but it's super important. In terms of power supplies for the addressable LEDs, I do recommend going back to BTF Lighting here on Amazon. Their power supplies I've used as well for a lot of my projects, and I highly recommend them. They've been really great quality as well. Typically, you can get away with using a brick power supply that has a DC barrel attachment if your power supply rating is going to be 50 watts or less. I believe BTF Lighting does have ratings, lower rated power supplies that aren't cages like this, but I think they're currently unavailable right now. Let me see if I can find that. But anything 50 watts and above, these right here, these cage power supplies are what I recommend. They do require a little bit more wiring. You do have to wire up a power cable to these, as well as wires from here directly to your microcontroller, but these will have enough rating for most higher end projects or projects that do take up a ton of LEDs. And it's nice because BTF Lighting does have a nice selection with different ratings. I did actually have to choose this 5-volt 60 amp option for my Gingerbread City light show project this past winter, and it definitely helped me with all the different LEDs I had on that project. Considering I had almost 800 LEDs, that really helped and was able to run all of those pretty easily. I do also have a bunch of these power brick style power supplies for a lot of my smaller projects that don't require a lot of LEDs being addressed. So you can see these have a little brick, they have a power cable connector, and they also have a DC barrel port. Those work great for those controllers back there, the two on the ends like I told you earlier. I use these quite a bit as well. Not this particular brand because I think BTF Lighting doesn't have the ones I use from them available at the moment, but I do utilize these for a lot of my smaller rated projects, usually when the power rating is 50 watts or below. BTF Lighting also offers these 15 watt and 30 watt options as well that are wall outlets that have a DC barrel plug as well. So this could be an option for me down the road as well if I have a smaller project. I think these are a little bit newer, at least I haven't seen these as much as the little brick power supplies. Anything larger than that, you're going to want one of these cage power supplies that I mentioned here. These aren't terribly expensive. They have gone up in price in the last couple of years just because of inflation and the economy and everything. But all in all, you want to make sure you have the right power supply for your addressable LEDs in your project. Now, I have been talking a lot about the addressable LEDs in this video as of late, but I want to switch back over to the non-addressable LEDs here when it comes to your power supply selection. If you are using the non-addressable LEDs or the battery or USB powered LEDs, the power supply selection calculation stuff that I just talked about isn't going to apply to you. Instead, what you're going to do is you're going to source, I recommend like a battery pack or a little portable charger that has a USB port on it that can power out your LEDs. If you're at an event or something, they're really great. I use those all the time when I go to events. A little power bank usually will be fine and sufficient for your project, as long as the power supply is rated higher than the power on the LED strips that you're using. Again, double check the specifications and the listings. They should give you all of that information. If they don't, I do not recommend buying those LEDs. A lot of times when I'm traveling to rep festivals, I will actually substitute some of the addressable LEDs out of my projects for non-addressable LEDs, just so that way I can use a power supply that's a little bit more portable for me to utilize, such as a little portable power charger, or even bringing my laptop and plugging them in through USB. So there are options in that realm as well, and quite frankly, those could be a lot easier than trying to do a lot of math involved and picking out the right power supply if you're using the addressable ones. There are options on both sides, so hopefully that can help you along your way. All right, so we've talked about the LEDs, we've talked about microcontrollers, and we've even talked about power supplies. We've talked more about electronics in this video than we have 3D printing. So, taking all that information we just learned, how can we take that and combine it into 3D printing projects to make our project stand out? This is the question you all have been waiting for, right? Well, I'm about to share some tips and tricks that, with the help of 3D printing, can take all these LEDs and electronics we've learned about and turn them into fantastic projects. First things first, let's talk about filament. I guess that should be the first thing we talk about, because filament is going to play a huge part when utilizing LEDs in your 3D printed projects. When it comes to material selection for your LED project, it really doesn't matter what material you actually use. So you could use PLA or PETG, heck, even ASA or ABS. That really doesn't matter in this case. What it's going to come down to is the type of finish on that material and its transparency. On the record, I use PLA or PETG primarily for my projects, and I've never once had an issue with incorporating these LEDs with PLA or PETG parts, but it really comes down to if my material is transparent enough for the LEDs to shine through it. Typically in my projects, especially my LED light panel projects or the Jano Leaf projects, if you want to call them that, I typically resort to a cool white filament if I'm resorting to white filament. Now, depending on your application or project, you could also use a warmer white or a natural white, but cool white to me just seems cleaner, and I like the brighter look it gives when LEDs are reflecting off of that material. Typically, if your material isn't transparent, more than likely, unless your printed part is super thin, then you're not going to get the light shining through your part like you want it to and not getting the results you want. I do recommend any type of translucent filament though. Any translucent PLA or PETG in your inventory is going to work great for 3D printed LED projects. Translucent filaments are great because of their composition by nature. You're going to have light shining through those materials pretty easily as long as you keep it relatively thin. I use translucent LEDs in a lot of my LED lamp projects that you might have seen in past videos here on the channel. They work tremendously, and if you have translucent material in different colors outside of clear, you can get some really nice effects and shine through with your LEDs. This coincides with my next tip, and that is making sure your 3D printed parts are at a certain thickness for maximum LED transmissivity. I actually shouldn't say maximum transmissivity, more like optimum transmissivity, if that makes sense. Let me explain. In my personal experience with LED projects and 3D printed parts, you really want to make sure your 3D printed parts are usually not super thick. Typically, I like to keep my parts at a thickness of 1/4 inch or less, just because the way the WS2812B LEDs react within the material and how they shine through the material, but you don't want there to be any hot spots if the LEDs are too close. So having the proper part thickness on your 3D printed part is really going to help find that sweet spot that you're looking for. You can also mitigate this by designing your part to house the LEDs at a certain distance away from the front facing wall or surface that the LED is going to be refracting against. That's something you keep in mind as well. If you have your LEDs positioned in your 3D printed part too close to that face, then you might get some hot spots, you might get some bleed through that you don't necessarily want, or might not be as aesthetically pleasing as you might want. So maybe consider adding a wall or a preset space where your LEDs or your LED strip or whatever LEDs you're using can sit and have at least a little bit of distance, maybe 5 to 10 millimeters away from that surface that it's reflecting onto. Set those LEDs so they have room to kind of dissipate and even out a little bit better. Picture a flashlight you have and you turn it on and you shine it at the wall. If you have the flashlight really close to the wall, it's going to be a really condensed hot spot shining on the wall. Whereas if you back up a few steps, you're going to see that light kind of spread out a little bit more evenly. Truth be told, I really don't have an exact number. There's no exact science to how far to space these LEDs in your 3D printed part away from its front facing surface. It really just comes down to the project you're working on. It depends on the application of your LEDs, and just do some trial and error. See what works for you, what doesn't work. If you need to space the LEDs out a little bit further back, or if you need to bring them in closer so there's a little bit more LED brightness in your part, then go ahead and experiment around with that. That's really just something to think about while you're designing, so that way you don't have to prototype as much in the long run, and you can save yourself time and get your project done faster. Don't worry, I have been there myself. I have prototyped numerous times, and even with new projects, I prototype over and over again until I get the just right sweet spot of the part working as intended. It just takes time, it takes patience, and if you know all this ahead of time, you can save yourself a little bit of stress knowing that you probably will be able to get this done in a lot less iterations than I used to do it. And just remember, fail just means first attempt in learning. Just remember that while you're working on this. Now, before I wrap up the video, I do have a few more additional tips regarding your 3D printed parts and your 3D printed designs that are going to make working with LEDs a lot more enjoyable. If you are using an LED strip or wrapping LEDs around a perimeter of a 3D printed part, I recommend that you design the part to not have a direct 90-degree angle from one surface to the next, because wrapping those LEDs around those walls, you're gonna have a tough time meeting that 90-degree angle in the LED strip. While the LEDs are flexible in nature, getting 90-degree angles out of those lights is super tough to achieve, and the 3M adhesive isn't the best. It's not the highest quality adhesive, so those corners are going to kind of peel off, and you're not going to get an actual 90-degree angle with those lights. Consider making a fillet on those designs in the corners that has a much more rounded corner. That way your path for your LEDs is a lot less strenuous on those corners, and you'll be able to wrap those around much easier, and you also won't have any issues with kinks in your LED strips and the potential for LEDs to not function properly. I'm telling you this because I have done this myself, and I have still not learned up to this day, but for future projects, I am actually making this note myself. Case in point, my square LEDs back here in the back right corner, I actually wired LED strips in each square, but because those squares didn't have a rounded radius on the inside, trying to get those to reach those sharp corners was very inefficient and ultimately didn't work out that way. I still got the LEDs wrapped around each of the panels the way I wanted to for each of the diffusers to work correctly. This kind of leads me into my next tip when it comes to 3D designs, and that is to consider adding a groove or a walled off area in your 3D part to allow your LEDs to be seated and have a place for those LEDs to be seated in your project. This also guarantees your LEDs are going to be in the same spot in your project, and you don't have to guess and check where exactly they are from your model to real-world applications when you're actually building up your project. It also makes applying the LEDs in that area a lot easier, and there's less likely risk of them pulling away from that section or peeling up from the part if you're using the adhesive. Next, consider where your power supply and electronics are going to be housed within your project, whether everything is going to be housed internally within your 3D parts or if you're going to have everything situated externally from your 3D printed parts. In my experience, I personally keep all of my electronics external, more or less because the electronics and the LEDs I'm using are much larger than the 3D parts that I'm printing for my projects. However, in some instances, I will create enclosures for the electronics. If I'm using those smaller power bricks and smaller ESP devices for the microcontrollers, I have designed and 3D printed little enclosures to sit underneath the LEDs and the LED panels. I actually did that for a set of LED lights that I made for my sister and brother-in-law not too long ago, and it was a way to kind of just hide all of the wiring and keep it a cleaner look. However, for me, I personally just try to hide the power supplies as best I can and hide a lot of the wiring as best I can. I could add some more wire channels to kind of hide those wires dangling from the walls a little bit to keep it even cleaner. But for my preference, I am okay with it, but you do what's best for you and your project. For my little power brick power supplies I'm using for my smaller LED projects in the corners here, I actually have the power supplies taped to the wall with some command strips and kind of tucked away from the viewing angle, so you really can't see it unless you forcibly look back there in those bottom lower corners of the camera. But my cage power supplies for my bigger projects, I usually have sitting on a table or a workbench and have enough space behind the project usually so that all the wiring from the power supply can be run cleanly and to the outlets without any issues. Again, use your discretion here on how you want to handle that. It's really just kind of keeping it as clean as you want to, and depending on how your project goes, you can decide what's best for you. When it comes to print speeds for your 3D printed parts, I also recommend any translucent filament you might be using to consider printing it a lot slower than your typical standard profile that you print at. In my past experiences, printing filaments at a much slower speed, especially translucent filaments at a much slower speed than my typical profiles, usually result in a better surface finish on your parts, making the surface finish a little bit more clear and more transparent. So if you really want the LEDs to shine through your 3D printed parts, I do suggest slowing your prints down. I don't necessarily know the exact science behind this. Maybe it only applies to larger layer lines or larger layer heights. So if anyone knows what that does actually, or knows the exact science behind that, let me know down in the comments. I'd like to learn about that. I just know printing at a slower speed usually gives me a nicer surface finish and really lets the LEDs stand out in my 3D printed part. Lastly, when it comes to designing 3D parts for your LED projects, consider adding ventilation in multiple areas to allow airflow for your electronics. Like I mentioned earlier, addressable LEDs especially, they do draw a lot more power than your standard LEDs you buy off of Amazon that are USB powered. So they are going to run a little bit warmer over time. They typically don't overheat, but I do recommend adding some ventilation areas, a couple areas where airflow could flow in to where your LEDs are sitting, so you can prevent overheating with your LEDs and any subsequent electronics nearby. Again, it doesn't have to be anything large. It's going to also depend on your project and application if you can do so pretty easily. Just something to not have it constrained in a completely closed off area where the LEDs could overheat over time. All right. Well, with that, I have given you the keys to the kingdom here. Well, the LEDs to the kingdom, let's say. And I believe that's going to wrap up this video on adding LEDs to your 3D printed parts. All of these tips and everything I've recommended to you today are going to take your 3D printer projects to the next level when you add LEDs. I love adding LEDs to my projects. I think they're super cool. It's become one of my favorite things to do. It's become kind of a niche of mine in this channel and in my content, and I look forward to continue to create LED 3D printed projects to show for you guys and to make bigger and better projects to show all of you and to grow my knowledge and skill set as well. If you'd like to check out my older LED project videos on some of my past projects where I break down certain topics in a little bit more detail, I'll put links to those in the description as well, so you can see some of my past experiences and what I did verbatim, so you guys can get some inspiration on your next project. Also, I know this was kind of a crash course on LEDs, microcontrollers, power supplies, and all that other fun stuff. If you have any other additional questions on anything we covered today that I didn't necessarily cover but you would like to know about, let me know that in the comments below as well. Let me know, ask any questions you might have, and I'll do my best to answer them. Also, if you made it to the end of the video here, thank you so much for watching this far. And if you enjoyed this video today or enjoyed any of the content presented today, give this video a thumbs up. That'd be greatly, greatly appreciated. And if you're not subscribed to the channel, please go over and subscribe. It's greatly appreciated, and we look forward to welcoming you into the community with more videos to come. Also, hit that notification bell so you'll know when those videos are here to hit the channel. Again, I also live stream on Twitch a few nights a week where I'm usually working on my 3D printing and LED electronic projects in real time with the 3D printing community on over there. So go check me out over there, and I'd love to see you in a live stream soon. So come say hi. With that being said, I'm gonna get back to work on my latest 3D printing and LED project. So thank you so much again for being here. I greatly appreciate every single one of you, and I'll see you all in the next video. Take care, and until next time, everybody, keep doing it big.